Origin of Earth. The origin of the Earth is a topic of scientific inquiry that has been studied by geologists, astronomers, and other scientists for many years. The prevailing scientific theory regarding the origin of the Earth is known as the nebular hypothesis, which was first proposed in the 18th century by the philosopher Immanuel Kant and later developed by Pierre-Simon Laplace in the 18th and 19th centuries. According to the nebular hypothesis, the formation of the Earth and other celestial bodies in the solar system began with the collapse of a giant molecular cloud, or nebula, composed mostly of hydrogen and helium, along with traces of other elements. The collapse of the nebula was triggered by the shock wave from a nearby supernova explosion or the gravitational disturbance caused by the passage of a nearby star. As the nebula collapsed under its own gravity, it began to spin and flatten into a spinning disk, known as the protoplanetary disk. The center of the disk became denser and hotter, forming the Sun, while the material in the disk started to clump together due to gravitational forces. These clumps, known as planetesimals, collided and merged over millions of years, gradually forming larger bodies called protoplanets. One such protoplanet eventually evolved into the Earth. As it grew, the Earth's gravity pulled in nearby debris and dust, further increasing its mass. The collisions between these protoplanets were often violent and caused a process known as accretion, where smaller bodies merged to form larger ones. Over time, the Earth acquired its spherical shape and developed a layered structure, with a dense metallic core, a molten mantle, and a solid crust. The early Earth was a hostile environment, with a thin atmosphere composed mostly of volcanic gases. However, as the Earth cooled, water vapor condensed and formed oceans, and volcanic activity released gases that gradually created the Earth's current atmosphere. It's important to note that while the nebular hypothesis is the most widely accepted explanation for the origin of the Earth, scientific understanding is always evolving. Ongoing research and new discoveries continue to contribute to our understanding of Earth's origins and the processes that shaped our planet. Certainly, here are some additional details about the origin of Earth. Formation of the solar system. The collapse of the giant molecular cloud that gave birth to the Sun and the protoplanetary disk also led to the formation of other celestial bodies in the solar system. These bodies include the planets, moons, asteroids, and comets. Differentiation. As the Earth grew in size, it underwent a process called planetary differentiation. This process involved the separation of materials based on their density. Heavier elements sank toward the center to form the core, while lighter elements rose to the surface. This differentiation process resulted in the formation of the Earth's distinct layers: a solid inner core, a liquid outer core, a solid mantle, and a thin solid crust. Late heavy bombardment. During the early stages of the Earth's formation, the solar system experienced a period of intense bombardment known as the late heavy bombardment. It is believed that around 4 billion years ago, the inner planets, including Earth, were bombarded by a large number of asteroids and comets. This period of intense impacts played a significant role in shaping the Earth's surface and potentially delivering water and organic molecules necessary for the development of life. Origin of water. One of the fundamental questions regarding the origin of Earth is the source of its water. Scientists believe that water was present in the molecular cloud from which the solar system formed. As the Earth formed and cooled down, water vapor condensed and accumulated, eventually forming the Earth's oceans. Impact of life. The origin and evolution of life on Earth had a profound impact on the planet's development. The emergence of photosynthetic organisms, such as cyanobacteria, led to the production of oxygen through photosynthesis. This oxygen accumulated in the atmosphere and contributed to the development of aerobic organisms and the formation of the ozone layer, which shielded the Earth from harmful ultraviolet radiation. Moon formation. The formation of the Moon is a significant aspect of Earth's origin. The prevailing theory is the giant impact hypothesis, which suggests that a mass-sized object, often referred to as Theia, collided with the early Earth about 4.5 billion years ago. This collision ejected a significant amount of material into space, which eventually coalesced to form the Moon. Early atmosphere. The early atmosphere of Earth was primarily composed of gases released from volcanic activity, including water vapor, carbon dioxide, nitrogen, methane, and ammonia. As the Earth cooled, water vapor in the atmosphere condensed and formed the oceans. Over time, the atmosphere underwent changes through various processes like volcanic outgassing, the emergence of life, and interactions with the Earth's surface. Formation of continents. The Earth's continents have not always existed in their current form. The process of continental drift, driven by plate tectonics, has been responsible for the movement and reshaping of the Earth's land masses over billions of years. Continents have collided, separated, and recombined through processes such as subduction and seafloor spreading, leading to the formation of mountain ranges, ocean basins, and other geological features. Early climate and habitability. In the early stages of Earth's history, the planet experienced extreme conditions, including intense volcanic activity, high temperatures, and a lack of oxygen. Over time, as the planet cooled and life emerged, the composition of the atmosphere changed, making Earth more habitable. The presence of liquid water, a stable climate, and the development of a protective ozone layer allowed for the evolution and diversification of life on Earth. The role of meteorites. Meteorites have played a significant role in the study of Earth's origin. By analyzing the composition of meteorites, scientists have gained insights into the chemical makeup of the early solar system and the processes involved in the formation of planets. Meteorites also provide evidence of organic molecules, such as amino acids, which are building blocks of life, further supporting the idea that the ingredients for life may have been delivered to Earth through impacts. It's important to note that the study of Earth's origins is an ongoing scientific endeavor. New discoveries and advancements in scientific research continually contribute to refining our understanding of how the Earth and the solar system formed. Understanding the origin of Earth is a complex field of study that involves interdisciplinary research from various scientific disciplines, including astronomy, geology, geochemistry, and planetary science. Scientists continue to investigate and refine our understanding of Earth's origin through ongoing research, technological advancements, and new discoveries.